This video will show examples with monomials.
Let's begin by simplifying an exponential. Expression. We can start with 15 over 3. We know that this equals negative 5. Now, c squared over c is the same as c squared over c to the power of 1. And using our power rules, we can say that this is equal to c to the power of 2 minus 1, or just c. And then, d over d to the power of 4 is equal to d to the power of 1 over d to the power of 4, which is d to the power of 1 minus 4, or d to the negative third. And this is 1 over d to the third. And so then, combining all of these together, we find that our final answer is negative 5c over d cubed.
Here's a more complicated one. So we will begin by raising both the numerator and the denominator to the power of 3. Then we can separate the product. So a to the 4x to the power of 3 times b squared to the power of 3 over negative 6 to the power of 3 times ax to the power of 3 times b to the negative fifth to the power of 3. And this equals 18 to the third times a 4x times 3, or 12x, times b to the power of 2 times 3, or 6, over negative 6 to the third times a to the power of x times 3, or a to the power of 3x, times b to the power of negative 5 times 3, or b to the power of negative 15. And now, the constant term in front is negative 27. We can take a to the 12x minus 3x, and then b to the 6th minus negative 15. And so this reduces to negative 27 times a to the power of 9x times b to the power of 21. Let's convert these to scientific notation. We can begin by writing out the digits that we want, and then we count 1, 2, 3. We have to move our decimal point 3 times, so that means we're multiplying by 10 to the third. And it's negative because we're moving our decimal point to the right. Here we want 9.325. We're moving our decimal point from here over 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 times, so times 10 to the ninth. Let's convert these numbers into standard notation. Since negative 4 is less than 0, we begin by writing 4 zeros. 1, 2, 3, 4. We put the decimal point after the first one, and then we just write down the rest of the digits. Since 5 is greater than 0, we begin by writing the digits, and then we add zeros until there are 5 digits following the 5. So there are 5 digits here. Let's try to use scientific notation to simplify some multiplication and use our rules with powers. So here what we can do is rearrange our multiplication, and then we know that this gives us 9, and then using our rules for powers, we know that this gives us negative 8. And so this is our answer in scientific notation. We can do something similar here. So 5 times 2 times 10 to the 7th times 10 to the negative third. This will give us 10 times 10 to the 4th. But in this case, This is not in scientific notation because we need the decimal point to be between the 1 and the 0. So we can convert that by moving the decimal point over once and making that 10 to the power of 1 and then bringing down the 10 to the 4th that we had. So our final answer is 1.0 times 10 to the 5th.